Hello all and welcome to another video on techacad.net. In this video, we shall be configuring IPsec site-to-site VPNs on Cisco routers using CLI method. So let's get started and see how this works. So before jumping right to the CLI command line box, and we need to have some understanding about IPsec VPNs. So what are the IPsec VPNs and what parameters are required to configure the IPsec? So IPsec is a secure network protocol suite that authenticates and encrypts the packets of data to provide secure encrypted communication between two computers over an IP protocol network. So this is the definition which is available on Wikipedia and Google. So you can check it out. So there are, what you need to understand is that there are two phases available for IPsec, where one is IPsec, which is named as IKE, phase one. And there are a couple of parameters which must be matched between these two, between the peers. In this case, R1 and R3 are VPN peers. And the IKE parameters must be matched between these two peers in order to have a successful phase one security association. These parameters are listed over here. You can see. Let's go up this. Yes. These parameters are an encryption algorithm, hashing algorithm, authentication method, key exchange, and lifetime. You can see that in this lab, we shall be configuring AES 256 on both the routers R1 and R3, and hashing algorithm is being used as SHA-1 on both these routers R1 and R3. Authentication method is pre-shared, and we shall define this pre-shared key, which is VPN PA55 on both of the routers. Next is e-exchange, which is Diffie-Hellman group 1, 2, and 5 are available currently on these routers, and we shall configure Diffie-Hellman 5 for extra security on these routers. So these are the 5 parameters which must be matched in order to have a successful IPsec phase 1 negotiation. So there are a couple of phase 2 parameters as well, which are ESP, and there are two protocols, ESP. Before going to the ESP, there are two protocols for the phase 2, which is ESP, and the other one is authentication header. ESP provides more security than AH, so we are using ESP in this case. So for security encryption, we are using ESP AES encryption method, and for authentication, we are using SHA-HMAC on both of the routers at R1 and R3. So the traffic to be encrypted, we need to have an access control list configured both on the routers R1 and R3. And we shall create a map, a crypto map, which shall be named as VPN-map. This does not need to match on both the routers, but for simplicity, we shall be creating the crypto map with this name. So lastly, we shall identify this VPN map with IPsec-ISAKMP crypto map. So let's move on to the command line interface for configuration of IPsec VPN connection between R1 and R3. So let's log into the R1. Type in enable and type this enable password for and for configuration mode, we shall type in config T, and we shall, but before proceeding to the configuration part, we shall enable the license for security technologies package, which is not available by default, but we shall install an evaluation package so that we can configure IPsec VPN on Cisco routers. So I shall copy this command. I shall also make sure to have this available on the video description, so you can use it on your time. So the command is license boot module C1900 technology dash package security K9. So I have copied this command and I should paste it over here and hit enter. It is asking to accept the end user license agreement. Hit type in yes and hit enter. License has been installed, and we shall save the configuration by typing UWR and reload the router so that configuration can be enabled by default. So we shall repeat the same process on R3, which is enable the security technologies package. Type in the password, console password, type in enable password, go to configuration mode and paste the same command which we have copied earlier. Accept the end user license agreement and copy the save the configuration and reload the router. So over here on R1, it is back. So type in the console password, type in enable and type the enable password. Go to the configuration mode by typing the config space T command, and now we shall create access control list to allow the traffic between R1 and R3. So access dash list. So we shall create an extended list by typing in the number 110 with an action to permit IP 192.168.1.0 and /24 wildcard subnet mask 0.0.0.0, sorry, 255, and destination of 192.168.3.0 and /24 wildcard subnet mask. So we have created access control list on R1. We shall repeat same process on R3. Type in enable and type in the enable password. Go to the configuration mode and create access dash list 110 with an action to permit IP traffic between the source 192.168.3.0 with the wildcard mask of 0.0.0.255 192.168.1.1.0 with wildcard mask of 0.0.0.255. So we have created access control list on both routers R1 and R3. Now we shall create IPsec phase 1 configuration on R1. So for that purpose, type in the command crypto ISAKMP. This is the negotiation protocol which is used by IPsec suite of protocols. So crypto ISAKMP policy and the policy and the number of the policy, for example 10, and here we shall enter the encryption, the parameters which we have discussed earlier. Encryption is AES 256, authentication is pre-shared, and group is 5, and let's exit out of here. Lifetime is 84,600 by default, so we shall not configure over here. Next we shall type in the command crypto ISAKMP key. This is the pre-shared key which has been mutually um, agreed upon by the peers, and we shall configure over here VPN PA55, and address is the address of the remote peer, which is 10.2.2.2. So phase one configuration is almost completed on R1. So we shall perform the same steps on R3 crypto, ISAKMP policy, and the number of the policies is 10. Encryption is AES 256. Authentication is pre-shared key. Group is 5, and exit out of here and crypto, ISAKMP key, and this key must be same on both the routers, and the address of the remote peer is 10.1.1.2. So phase one configuration is also completed on R3. Next, we shall create phase two configuration on R1 by creating a VPN set transform set. So for that purpose, type in crypto IPsec transform set, and the name of the transform set is VPN-set, and the parameters are ESP-AES and ESP-SHA-HMAC. Next, we shall create crypto map VPN-map, and sequence number is 10, and we shall identify this VPN map with the IPsec ISAKMP. And it is asking to attach it is asking us to attach to set the peer and access control list in this VPN map. So we shall first describe a description to this VPN crypto map, which is connection to R3, and the peer for the R1 is R3, IP address is 10.2.2.2, and the transform set which we have configured earlier is transform as VPN -set, and the access control list which we have configured for this VPN is 110. So exit out of here, and next we shall attach this VPN map with our interface serial 0/0/0 by typing the command crypto map VPN-map. So you can see that ISAKMP is on. So let's configure phase 2 on R3 by following the same steps. Crypto IPsec transform set VPN-set ESP-AES ESP-SHA-HMAC, and we shall create a crypto map with the name of VPN-map with a sequence number of 10. You can create multiple VPN maps with sequence numbers, and we shall identify this VPN map with IPsec-ISAKMP. So the description for this VPN map is crypto map is connection to R1, set peer address is 10.1.1.2, set transform set is VPN-set, we have configured earlier in this router, and match address is the match the access control list of 110. Exit out of here and attach this VPN crypto map with the interface serial 0 by 0 by 1, and by typing the command crypto, sorry, map VPN dash map. So you can see that ISAKMP is now on. You can verify the status of IPsec VPN by typing the command show crypto IPsec SA security associations. So you can see over here that the serial 001 is the interface which is tagged with VPN map, and local address is 10.2.2.2. The local LAN address is 192.168.3.0 with, and 192.168.1.0 is the remote remote address, LAN address. So you can see that there are no traffic going on over here. So we shall try to create some traffic by typing the, by trying to reach PCA IP address. We can verify that 192.168.1.0 and PC3 IP address is 192.168.3.0. So we shall ping 192.168.3.3. First two packets might be failed because ARP is not learned by the PC. So request is timed out. And you can see that now request, now we have received a reply from PCC, which is 192.168.3.3. And if we trace, if we again repeat the command, we will receive 4 packets out of 4. So if we trace 192.168.3.3, so you shall not see the IP address of R2, rather you will see the IP address of R3 as the next hop. First hop will be the gateway of address, and the next hop will be the R3 IP address. As you can see that 192.168.1.1 is the IP address of R1, and 10.2.2.2 is the IP address of VPN peer R3. So the traffic is being encrypted between R1 and R3. If we see the statistics on the router by typing the command show crypto IPsec SA, you will see that packets are being encrypted and decrypted over here, and you will see that VPN status is now active. So if we reach the PCB, which is 192.168.2.3, you will see that the traffic is being traversed from R2. 192.168.2.3. And now we trace 192.168.2.3. As you can see that 192.168.1.1 is the gateway address on R1, and 10.1.1.1 is the IP address on R2. So the traffic between R1 and R3 is encrypted, and the R2 is acting as pass-through for the traffic for this LAN subnet. So I hope this has been informative for you, and I would like to thank you for viewing. If you liked the video, or if you have learned something from this video, please subscribe our YouTube channel